Okay, welcome everybody. I will be welcoming everyone in the room here to ThaiPy, as well as everyone who is online. Welcome. So this is our first hybrid event. Almost the first one. We did one just at lockdown last year, I think March last year, April last year. But this is our first time to do it properly. So we're doing a few different things. In order for everyone to ask questions, whether you're in the audience here or online, then there's Slido. So I think there's a link and a QR code that you can join. So we're also going to be having a thing called GatherTown, which is allows sort of audio conferencing and talking, so that you can have discussions for if you're online and you are want to discuss during the breaks, because you can't network and discuss things here. So the general format for ThaiPy, we have two different talks. We'll have the first talk being SeokJin in Korea, and he's going to be joining us from Korea live. And then we'll have a short break of about 10 minutes, and then I'll talk from here, from ASDC in Bangkok. And then for those here who want to join us, Microsoft have kindly offered to sponsor the after event for those who can make it, which will be at a nearby venue. What else do I need to say? So thanks very much to AIS for sponsoring the venue. Thank you very much for Microsoft for sponsoring the food and beverage. If anyone's got any announcements, come and see me during the break, or send a message through. And so we're going to start off by getting everyone involved on this Slido thing. There's a quiz. So you will get a, what's the prize, Georgie? It's a tumbler. Yeah. So everyone log into Slido. You can use the QR code there, or you can enter that code there. And there is a responsible AI quiz, which everyone can fill out now. Ready? Are you ready? Has everyone got their phones out? If you are absolutely welcome to compete from home, please do. We'll just have to work out how to get the tumbler to you. Okay. Is it live? Join the quiz. Do we see the answers come in live? Oh, there we go. Cool. Okay. Now, at any time during the talk, you can ask your questions on here. Other people can see the questions if they want. And the way it'll work is that we'll read out the questions at the end. You can also ask questions here directly. Okay.
Is there someone who wants to all in?
Alive?
Did you actually look up different definitions of AI? Okay. Oh, so it does it on time as well? Okay. And Kitpong, okay. What ethical concerns do creators of artificial intelligence have to consider? Please click those that apply. Whether or not their invention will be used for war, possibility that AI will become conscious, the amount of human jobs that could be lost, whether or not their inventors will make people's lives worse.
Whoa.
Oh, that's a pretty good spread. There's a correct answer for this one?
They're all good.
I would have put how much you get paid as an AI researcher. The Chinese box experiment tries to prove that Chinese language is difficult for anyone to comprehend, that people are essentially machines, or computers favor one language over another, that a machine can't consciously think. Aha. Is it that machines can't consciously think? Hey, I got it right. Okay, Chris. No, Patrick. Patrick is here or online? Is Patrick here? Oh, okay. 3 of 8 questions. Okay. There you go. What is machine learning? Machine learning is a technique that uses mathematics, statistics to create a model that can predict unknown values. Machine learning is a field that uses scientific methods, processes, algorithms, systems to extract knowledge. People can read this themselves. I just don't know what to do while I'm sitting here. That wasn't enough time to read the questions. Okay. Yeah, Patrick's still in the lead. Mm-hmm. Trait humans, language intelligence, the ability to accumulate written knowledge, and the ability to feel pain. Oh, we have a new leader, Mr. Andrew. So the following is not an example of intelligence. Using logic, adaptive behavior, making tools, cells converting food to glucose for energy. What about being a tool?
We'll talk about it.
Okay.
Next.
Click all the traits that some animals may share with humans. The creation of hierarchy in their societies. Certain members are in charge. The ability to communicate specific directions, food sources, the ability to use language, and the ability to coordinate and organize. For those people who just entered, this is a, please join for this, not just to answer this quiz, but also because it will help you ask questions of the speakers during the event. Last question. Okay, and who's the winner?
Okay, let's see who's the winner.
Mr. Andrew Purser.
Whoa!
Yay. Okay, we'll present you with your Tumblr after this. Okay, so let's get on with the talk.
Say hi to him first.
Oh yeah, of course. Okay, so SeokJin, welcome all the way from Korea.
Hi.
Yes, oh, there we go.
Hey,
Okay,
hey everyone.
So he can see us?
No,
Yeah, I got cables everywhere.
sorry.
We can. There's people here. Okay. We can add a phone in, can't we? Anyway, so I'd like to welcome SeokJin Han, all the way from Korea, who's going to be talking about responsible AI from Microsoft. So without further ado, please take over.
Yeah, thanks a lot, Dylan. Thanks a lot, everyone. Actually, I am on the Gather Town as well. I only see just a few people, but how many people are in the site? Can someone talk? Yeah, it takes time to come back. Oh, okay. All right. Thanks a lot. Wow. Okay. Hey. Great to see you. All right. So that quiz was interesting. Especially it helps you wake up after a meal, right? And that actually was a good set of questions. The topic that I brought here today is about responsible AI. I don't know. Well, I hope that I can put some polls here, but just because of the time I have, I'm assuming that all of you are Python developers or using Python at the least. Probably you are a basic. You're learning how to use it. Some of you are very advanced and hardcore Python developers. The area that I'm talking about today is machine learning, and especially when it comes to responsible AI. How do you make sure that your machine learning models are something that you expect it to be? So I'm gonna talk about some tools to help you out when you're discovering if your models are behaving good. So let me get started. So thanks. My name is SeokJin Han. I'm from Microsoft, and I'm based out of Korea. But it's really glad to be here to talk about this topic. The agenda I'm thinking about is this. So what do we need to consider when we are dealing with responsible AI? That very briefly, I'm talking about some aspects, and then I'll talk about why we should care about this, and briefly introduce some approaches when you're trying to explain models. And then the majority of the session will be about showing you the demos, and I'll have some quizzes or questions for you. Not the quiz that we just did before the session, but some set of questions you might want to solve, and you might how you would find some answers to those questions. And I'll come up with the resources, and I hope that you can join the community and continue on. So for those who are willing to dive in while I'm doing this presentation, you can actually use this repo to get started. So there's this readme that markdown file. So you can clone this. You can start running some of those and actually play together. So let me just briefly talk about the aspects when it comes to responsible AI. It begins with the principles, because these are the principles and the aspects that Microsoft is looking at and executing on. So we started setting up those principles, including fairness, safety, inclusiveness, transparency, and many others, we try to reflect on these principles when it comes to responsible AI. So when we are dealing with, when you're making new AI models or AI-based services, we come back to these principles and see if we are meeting all those criteria. So on top of the principles, we are building practices. For example, the first one here at Ether Committee is one of the boardroom, board, where when you're building AI services at Microsoft, you need to get the approval and pass the review from this committee. So this committee actually the people there are from different area, including the compliances, the legal experts, and the business experts, along with the AI experts. So they are reviewing what we are building is what we are building is compliant to all the principles that we set for. So, and we believe that this is not something that a single company can do. So we are partnering with other companies and communities to build good practices. On top of that, we're building some tools that we can use together. So one of the things that I'm bringing here today is about the second one, Interpret ML. And that's kind of related to how you are explaining your model behaviors and check if it's okay to publish your model for the bigger application. So with these aspects, why this matter to you? Why this matters to you? Because once Albert Einstein said, if you can't explain it simply, you don't just understand it well enough. So do you really think that your model is something you have had in your mind? When you're evaluating your model, you talk about the accuracy as a whole, but the accuracy is enough? Well, we have many performance metrics when it comes to classification, regression, but are they good enough to judge if your model is working good? And especially when you're seeing good accuracy, for example, is it okay to make the call? So I brought some examples here. So on the left side, you wanted to train a classifier to classify between a husky and a wolf. So you built a husky classifier or wolf classifier. But at the end of the day, what you've trained might be the snow in the background classifier. So if the model is trained and it's working great with your test data, doesn't mean that it's enough. So sometimes, most of the times, no, I'd say all the times, you need to take a deeper look if your model is behaving correctly. And on the other side, on the right side, you're looking at a text classifier, text-based classifier. So here you are classifying the types of the documents based on the text in the document. And the left one, the algorithm one, is looking at the right set of information from the test data, from the training data. But the algorithm two on the right is actually, well, it's not a document classifier. It's actually looking for some less meaningful terms from HTTP or protocol-based technical terms, not the real content you should be looking at. So this is one of the examples, some of the examples that why you need to care about this model explainability. And if you look at the right top right, it's very small here. The more complex the model becomes, it's actually harder to explain. So if you're using deep learning models or stuff like that, just because it's harder to explain, are you going to abandon the opportunity to look closer into those models? So with that, there are a lot of ways to explain models, but at the end of the day, probably you want to look at two axes, two aspects. So this axis, the horizontal axis here, is about the local explanation and the global explanation. So global explanation, probably you are more familiar with this concept because when it comes to feature importance, what are the features that are most important to predict any values. So for specific task, probably this feature number 1 is most important, and the feature number 2 is the following, and the third one follows. But on the other side, there's this concept of local explanation, because globally this model is looking at these features very importantly, but for some reason there could be cases where given a specific data set or data point, these data points consider this feature, the other feature that is less important globally. So the local feature importance might be different from the global feature importance. And there are tools to look into these local explanations. And that helps because sometimes you want to understand why this model predicted this way, but these kind of understanding will help you understand why. Another axis, the vertical axis here, is about the model agnostic and model specific. So this one, model specific, means that there are some ways to explain models, and these ways, these methods, require a specific set of algorithms. For example, decision tree is known to be relatively easier than the others when it comes to explanation. Neural networks are less easy, so they are considered harder to explain. But when it comes to model agnostic methods, this can be applied to any models, any black box models. So, for example, deep learning models, literally all the nodes and layers, it's hard to trace what the data means. But with these kind of tools, you have a better chance. You have a better tools to understand. So these are the 2 axes that you may be interested in. There are a lot of tools and books and data sets and libraries out there. So I've just added some links, so you will want to look at them later. But I'm not going to talk about all these. I'm going to probably emphasize this one. So model agnostic and local explanation, because it means something for your more general purposes, for more general applications. So the rest of the session, I'm going to spend some time on showing you the demos, but the demo is not just a one-way demo. I hope that I'm going to ask you some questions. I don't know, well, this mechanism is not the perfect one because I'm not in the room, but I'm going to actually, I want to make you think about those questions when you're seeing this. So Interpret ML is one of the open source packages out there. Actually, it's developed and sponsored by Microsoft, but anyone can contribute and participate in this development. And Interpret ML comes with something that I'm going to show you. And probably this is the first question. So I'm going to show you along with the demo. This is actually a screenshot, and it's showing some models, and it's showing some performance of the models like accuracy, precision, recall, etc. But what it does is actually comparing between different cohorts. I'm going to show you how or what this means right now. So here I'm opening a Azure Machine Learning Studio, which is a machine learning platform you can use to train and manage your experiments and models, and you can package them as containers and deploy anywhere. But that's not the focus of today's demo. But what I'm actually doing here is, well, I'm going to use this compute, because this is the compute instance or cloud VM you can use for development. Because I have my Visual Studio here, I can use this. But at the same time, if there's anything wrong with my Visual Studio, just like it is now, I can open this. Oh, yeah. So if anything happens to your local desktop, but you have access to the internet and you have the web browser to use, then you can use this. So I go here, I can create a compute instance. I can choose CPU or GPU-based ones. But at the end of the day, the Jupyter Notebooks and Visual Studio integration, RStudio are all here. And I can click Terminal if you want to run those comments, I see that I think I had it open, but I think I need to open that again. Okay, my PC is getting slower, but I hope that I can finish it without too much issues. So here, you can do things like, you know, conda activate, explain ML because I want to use this. I can check out what packages are installed here. So just usual Jupyter Notebook experience. But what I'm doing is here, I can go to the notebooks that are uploaded here. I can open this notebooks. And this is actually the Git repo that I shared earlier. So you can take a look. And when I open this Jupyter Notebook, this is the usual book. And I'm using the Cloud VM to run this. So I'm just going to show you how to run this and explain just a little bit about the code here. So what I can do is I just import the packages that are needed here. So like GBM and the other stuff. And I'm downloading the file. That's just normal way to do it. So I'm downloading the file locally. I'm doing some feature engineering. So I'm transforming the data so that I can use it. I'm splitting the data into train and test data, also X and Y, so that I can use them to train the model and also test the model. I'm continuing with the feature engineering. This is another feature engineering. So, you know, stuff like that, the imputer dealing with the missing values. And then I'm defining the scikit-learn's pipeline. So I'm pre-processing the data and then use this like GBM classifier to train a model. So at the end of the day, when you do this feeding, this model has the pattern, has captured the pattern from your training data. So this is called the machine learning model. Now, what is interesting is using this model, you can use this tool called interpret.ext.blackbox, has the tabular explainer. And using this tabular explainer, you pass this model itself along with the trained data and the features and classes, etc. So you have come up with a new concept here, tabular explainer. And then what you do is you can get it to explain global. So it's using the X test data. So use this test data and see how the model sees the test data. Well, the following is not too unique, not too impressive. It's just normal because now you're looking at the feature importance at a global level. So globally, it's saying over time, stock level, stock option level, etc., with the following feature importance. Well, basically, the data set we are looking at is the employee attrition data. So each record is about the employee, and one record represents one employee. And there are features like these, and the target label we're going to predict is the attrition. So is this employee staying in the company, or is this company leaving the company? So you want to predict what employees want to leave the company and probably do a proper compensation or a compensation to retain the employees. So here you're seeing the global feature importance. So over time, yes, it makes sense because you're working overtime every day. It means you're not doing the good level of life and balance, right? A work-life balance. And stock level, yeah, stock option, you have a lot of stock option. Probably that's easier for you to make decision to just stay. So probably that makes sense. That makes sense. Monthly income also makes sense, and blah, blah, blah. So that's a very less impressive one. I could do something like this. This is a little bit more impressive because you're now specifying which data set you're looking at. And you're sending that data from the test data. So this test data has not been tested, has not been used when you're training the model. And you're sending this one data set and see how the model looks at the data. So the local explanation of the model against this specific data set. So now get the explanation. Basically, you can get the prediction. So the predictive value and the now you get the get ranked local values and names for the explanation. And when you print this for this specific data set, overtime is very important. But the second important feature was not stock option level. For this specific data set, marital status is more important than the stock option level. So this difference is something to look at, because you know why the model predicted this for this specific data set, because you have a better understanding of the model here. So it's very blunt, direct way of doing this. To explore better with this model behavior, actually there's a widget, Jupyter widget, that is created here. So here you are looking at something different, because you have the URL here, open here. I opened it separately. So when I click this one, oh, my web browser stuck. Let me try opening it again. Okay, looks like my browser is now working. Let me open. I hope that it works when I open a new browser. Oops, no, not this one. I'm gonna copy the URL. Hopefully it works. So it's running, yeah, good. So this is the widget for the explanation. So let me try this one. So the first question I had was, can I know, well, basically this is showing my model performance. This model performs with at an accuracy of 78% and precision of 94%. So this is good, looks good. But what if I set up some cohort here? So for example, I can say, does it work for female? So for example, I'm gonna unselect the male and save it, and I name it as female. Then it adds a new cohort called female. So all the data, the distribution looks like this, but the female is like this. And you look at the accuracy, actually the female, for female data points, the model is behaving better. You can add things like, what if the age is between 18 and 60. What if I set this one like less than 35, and I say like age is less than 35. Then I add another one called age is greater or equal to 35, and I name it as age is greater or equal to 35. Try this and see. So in this way, you can actually look at different cohorts, different data distributions, and how the model performance changes. So this is a good way, because it's not just about the global explanation. How does it work? How does it behave along with different cohorts? It's a great indicator, because you want to make sure that this model is performing well for all the target cohorts. So this is just a simple way to do that. And going to the second question, so there's the data explorer. So the questions here are not very impressive as it is, but actually you need to explore the data and make sure that you're looking at the right data. So for example, I can go onto the data explorer and see, for example, if the age, let me just try this. If people getting older, are they really leaving? And as an aggregate, you can do that, or individually, you can see if the people are leaving. Or, for example, let me just try this one. If I choose this one, monthly income. So as people grow older, the monthly income increases. But before making any decisions, probably you want to make sure you're doing the proper statistical analysis. But actually, well, the variation is growing as you grow older. And you're actually showing the predicted Y, but you can also choose the true Y or classification outcome like false negative and stuff like that. So this is the basic tool that you can use to look at them. But this is not very impressive so far. But you can also choose different cohorts and see how it's different. So that's the basic explanation. But what is more interesting is this. So what are the most important features and how the features affect the prediction? And does it differ from different cohorts? So let's just take a look at this. So this model thinks that if I choose 4 top features, these are the top 4 features that are most important. Overtime is the most important. Stock level is second. Monthly income, environment satisfaction. You can choose. You can compare with different cohorts. So that's something you can do. You can look at the box. So the mean and maximum, those you can check. And what's interesting is if you click this one, so you want to look at the overtime feature, and you click this all data, the whole population, then you see that for this specific cohort, for this specific feature, how important the feature is. So overtime Y has a bigger number here with some variation. Overtime No has less variation, but it's on the other side, in the other direction, but the absolute value is smaller. So it means overtime, when you're doing overtime, it's more probable that you'll be leaving. If you're doing overtime, not doing overtime, it doesn't mean it means less. I mean, to predict the probability of leaving. So comparing this absolute value here, well, if overtime is Y, it means more than the overtime when overtime is no. Similar things you can do like stock option level. So if you're not getting any stock, then it's a little bit more towards the probability of leaving. If you have some stock option, it's on the other side, so probably you'll be staying. But as the option level grows, it's less important. So you can actually compare between different values of the feature. So it's not just about the prediction, the comparison between different features, but within a single feature, you can compare how the feature importance differs between these actual values. So these are actually something that you can take a look to see how it does. Lastly, the last point that I wanted to make is about the local explanation. So I just showed you in the Jupyter Notebook that you can actually look at the local importance values, but it's not actually with this dashboard you can do more. So these are the data points you have, and you can pick one of those data sets. So I'm looking at row 284, and I see these values are the features of these specific data point. And here, you're looking at the feature importance plot. So this specific one has overtime as the most important one. Very good. If I choose another data point, it's being added to the plot. So now you're looking at 2 different data records, and you're comparing it. So for example, because I'm ordering this by row number 284, for 284, overtime is most important, and business travel is the second most important. But if I order by 134, overtime is most important. Distance from home is the second important for this one. I can choose other points as well. So you're comparing these 3 data points. And probably lastly, you can actually change some of those data. So for example, from 290, you can change some data, like you're at age of 30. What if I grow older, and what if with all the other features the same, if I age is 40, then the prediction is changing. So it's still predicting staying, but the probability is growing. So this way you can have a very quick simulation against the model. And another thing is probably this one, because this actually does the simulation over a continuous value for you. So if I choose age, all the other features are the same. Actually, when you grow older, you are more likely to stay with your company. So actually, you can look at the slope here. So for this specific data record, with this person is very likely to change to the staying mode. So this is something that you can take a look. This is just like debugging your components what you develop with Python, but you are debugging the machine learning model in this case. Well, that's probably the majority of the demo that I wanted to show you. One thing I want to add is the error analysis. This is the latest one on top of what I've just showed. So this one showed you something like this. So which segment covers the most errors and have the highest error rates? So let me just jump into that one. I'm gonna just open that from here. It's here, and you're looking at the same model. In this case, you are because you have the tree representation of the model. I didn't explain about this, but originally I trained the LightGBM model. It's a tree-based, forest-based model. But regardless of what algorithm you use, it's considered as a black box model. So, for example, if you use the deep learning models, deep learning algorithms to train your classifier, and you follow the path that I just showed you, then using Mimic Explainer, the specific explainer that I've used, this is creating a surrogate model for you that is behaving similarly to your original model. It's a different model, but it's behaving similarly. So using this surrogate model, you have a better chance to explain more. So a surrogate model that works that's easier to explain. That's the idea of here. So using this surrogate model, now you're looking at the cohort. So if you're looking at some of the nodes here, so if you're looking at this one has the error coverage of 85%. So of all the errors, 85% of the errors are happening under this node, and error rate is 45%. So of all the number of the samples, 85 were wrong. And well, you can take a look at this. For example, this one explains 72% of the errors. So if you fix this one, it's a better chance to minimize the error. But it's not just about the error coverage. For example, this one, it has just 10%, 9% of error coverage. So it explains just 9% of the model error. But the issue is with the error rate. So it's almost about 100% of them are incorrect, meaning that if you don't care about this specific cohort, well, going down from here, so you're married and your capital gain is larger than this, and your education number is smaller than this, this specific cohort, the model is behaving quite bad. So you want to fix this problem. So I think this one gives you that kind of understanding. So now you have better understanding of the model, where the errors are coming from, so that you can debug into this one and see how you can fix it. Another way is heat map. Let me go to this one. So this is just two-dimensional, but for example, if I choose this x-axis, you can see where the errors are coming from across the age group. Or you can actually add some others like race for example, so you see that some segments are indicating that you should take a look at those groups. So you can choose some of those, for example, and then you can choose to save it as a cohort. So these filters are automatically filtered, and you want to look at this cohort 1 and save it. Then you can go on to the explanation. So when you click this explanation, it's just about the same. I mean, we already talked about this data explorer, global explanation, and local explanation. When it comes to local explanation, what is a little bit better is you can choose multiple data set from correct predictions. And also you can choose some of the incorrect data set from here. And you can check out what the whole data set you chose. Then you can go ahead and inspect. And actually, you are looking at the very similar interpretation. So you can choose some of those and see how it goes. Or you can simulate and change some of the features and see how the prediction changes. So with that, actually, that's it for my presentation. FairLearn is another tool. This is another very exciting one because this is about really looking at the biases embedded here and trying to compare between different cohorts. But it's really about looking at the fairness aspect of that. And that's another one, but that's not part of today's session. So with that, we actually I just showed you how you do this under Azure Machine Learning. Well, these dashboards are open source, so you can use them without Azure Machine Learning, but you can also use them inside Azure Machine Learning because those dashboards are also integrated within the Azure Machine Learning. So hopefully we can talk about this later, but for now, I think that's it. So resources you can look at. So we're going to be able to share this session, the deck. Actually, it's in the GitHub repo that I've just shared. So that's it for now. You are welcome to join our community as well. So I think we, as a community, a global communities, we can do more together. So that's it. I'll be staying around for more time in the Gather Town. So I hope we can have more conversation out there. So thank you, and back to you, Dylan.
Do we have any questions online, or maybe start with the audience? Any questions here? No. Was there any questions online? No. Okay, so if we don't have any questions, then if you have any more questions, then yeah, SeokJin will be joining the Gather Town, which the chat line. So if you follow this bit.ly link here, if you're online, there's an area where you can chat together. And we will have a 10-minute break here for everyone to get up and talk to each other as well while we get ready for our next talk in 10 minutes. So 8 o'clock on the dot. Okay, thank you very much again, SeokJin.
Okay, thanks a lot.
Okay, so everyone could have a sit down. Okay. Okay, so now I'd like to, before I introduce the next speaker, there's a online conference this weekend called FOSS Asia. I'm not sure if it's Saturday and Sunday or just Sunday. I think it's just Sunday, and there is also a local viewing party as well. That will be held locally if you want to actually meet up with people and watch it. So it's kind of an online event, an offline on-site version of the online event. So if you're interested in open source at all, please check out FOSS Asia. Okay, so I'd like to introduce the next speaker, which is me. So, Dylan J. Thank you, Dylan J. Okay, off we go. So before we start, I'm embarrassed to say that this is the first time I ever used Ipython Notebook. I now realize, having done this whole thing, this was actually a much better way to develop the code that I developed for this. So I've learned a lot there. Okay, so how I like to, right. So what I learned a bunch of things in this. I started doing it because I knew how to parse PDFs. I'd done a bit of that before, but I ended up learning an awful lot more and using a lot of other tools. So I thought I'd like to share that. In particular, I never really used Pandas before. So disclaimer, I'm not a data science guy. I'm a web guy. I'd obviously seen a lot of talks at ThaiPy and other places about Pandas and about Ipython Notebook, etc., but I never really used it. So this is, you might see a lot of bad Pandas. So a lot of things that could be done better in other ways. So if so, I apologize. And you may see some things that really shouldn't be done to stats or graphs as well. So if so, let me know. Okay, so why did I do this? So back in sort of mid-January, Thailand had a second wave that happened that started about mid-December, and by late December, they stopped updating this graph on our word and data. So they stopped getting testing data, and the problem is when you have a lack of data is people start wondering things. They start, trolling on the internet, and they're saying like, oh, well, if there's no data, if there's no testing, then there's no cases, etc., etc. There's a whole lot of people, just a lot of mistrust going on, etc., etc. So I started to think, well, if we have data, then what's wrong? Huh? It's a phone. I can turn the one off the phone. It's annoying me as well. Okay. No, I can't. I can't actually turn it down. Okay. We don't need it. Okay. Yep. That's annoying me as well. Okay. So so a lot of people were, saying a lot of things, talking a lot of shit about, testing and this and that, and where they're testing, et cetera, and whether there's actually, lots and lots of cases out there. And that's been the case for a long time in Thailand. There's been a lot of different conjecture about how the government's handling things. So what I thought is, well, I could have a look at these different things and see if I can find the data and see if I can understand it a bit better. In particular, I'd seen this thing talked about quite a bit from the beginning of the pandemic called the person under investigation, which is, I think, a Thailand-specific term. But generally, my understanding is that it means people who have met a certain criteria where they've got and that criteria has actually changed over time. So the criteria is kind of a set of symptoms and whether they're at risk, like have they had contact with people, have they are in a risky area, and that at-risk thing has definitely changed over time. Now, my understanding is that means you get a free test. So generally, if the PUI count every day is going up, then it should be a good indication of how much testing is going on. So maybe it's not the exact amount, but it's correlated. And I'd seen that the numbers were around, so that my first step was to have a look at these numbers and see if I could, there must be some kind of source out there. So I looked all over for some sort of Excel spreadsheet or Open API or something that had these numbers in them, and that I could not find that at all. And also, so the thing that really kind of got me thinking about this is that this total number of laboratory tests. So I found that there's these PDFs, and they have, where are my PDFs? Okay, sorry. I learned how to use this properly. Okay, so if you go on to the Ministry of Health website, they have these situation reports. They're in English and in Thai. I'm just showing the English ones at the moment. And situation reports have a lot of interesting stuff in. They give you a bit of description about news and what's happening, how many cases there are, et cetera, et cetera. But they also have the statistics in them, like confirmed cases, et cetera. And they have this really interesting one down here, which is total number of laboratory tests. That's what I'm looking for, right? If I know the number of laboratory tests, and then I can combine that with the confirmed cases, we can work out positive rate. And the positive rate really helps us tell how much testing is going on or if enough testing is going on. So if I can get that data out for the whole year, then I can start to work out the positive rate. So I just need to get a whole lot of PDFs and start collecting that data. So how hard can that be? So first thing I looked in was a package called Tabular. Tabular is helps you extract tables from PDFs. And that for this particular one, it works reasonably well. It goes and got those different data that we saw there and puts it into tables. It's still got a bits and pieces of in there. So this is going to be right. So we've got the second page now, and this has got the one that we're looking for, right? We're looking for the total number of laboratory tests and the people who met the PUI criteria. Okay, but so the tabular didn't work for all PDFs. In particular, it doesn't work for the Thai PDFs, and the Thai PDFs are actually more up to date. It's also a little bit slow. You saw on there, like when I was reading the data, it's like if I'm going through 100 PDFs, it actually adds up. And the other thing is that, yeah, you have to kind of tell it which page it's on. So if the pages are not there, then there'll be a bit of a pain. And if it doesn't work at all, then you just get nothing, right? Like you've got no back down from there. So in the end, it was like, okay, I need to use a better tool, different tool for this. So here's an example of what a Thai PDF looks like. This is the same report. They put some nice pretty graphics in that one. But you can see why the tables probably don't work here because it's not actually a table.
The graphics,
it's just a picture, yeah. If you want to extract information out of that, then you have to use some image recognition or something. So if we see, we can see tabular tell us that we've got nothing in there. Okay. Okay, so next was Tika. Tika is something I'd used before. It's actually Java on the back end, I think, but the Tika Python just installs and does all the Java stuff in the back end, so you don't need to ever see that Java's involved, which is nice. It's quite cool because you can throw all sorts of document formats at it. Later on, I'll talk about PowerPoints and so on, and you can just throw a PowerPoint at it, and it'll also give you text. What it does do is just give you text, though. It doesn't give you any kind of structure out of it. So let's import Tika. And that gives us this text version of the report, and then when we go down here, we can start to see the numbers. Okay, so I just got to do a little bit of text processing on that. That's fine. So I wrote a little routine. It's pretty basic. It's not anything fancy, but all it's doing is I've got a bunch of different words that I'm looking for. When it finds a word that I'm looking for, it then gets all the numbers, everything that looks like a number after that in a big row. And I'm assuming that all the numbers are in line in the same order so that I can then pull them out. A little bit of an assumption, but it works for this case. Right, so if we're getting the content there, we're looking for this regular expression here, total number of laboratory tests, then we get the laboratory test, then we get the PUI, then we get whatever came next, etc., etc. So that's working well. So next thing, I need to actually get all the reports. So I wrote a little routine that takes a page and gets all the links out of it. That's pretty straightforward. Then I wrote a slightly longer routine that gets all those links and downloads them. So there's a few things that happening here. I don't know if I showed that, but I had to do some things like their web server is like a little bit temperamental, so sometimes it would be slow and not return things. So I had to use this retry mechanism for requests. So it would do an incremental backoff. It'll wait, 30 seconds or something before it tries again, because I wanted it to be reliable. What else am I doing here? I'm doing a last modified check because apparently they do change some of these figures and stuff like that. So I am caching the files locally, and if they are modified according to the server, I will download the new version. And other than that, and I'm doing the parsing directly in here, but that's pretty much all it does. Okay. Right, so if we do that, that goes and gets us all the particular files. Okay. So putting it all together, now it starts to get a little bit messy, right? When you put all this together. So it turns out that, my initial search term here only works for half of them mid-year somewhere. Then they changed the reports early on. The early reports don't have the same stuff. They didn't have this laboratory test thing. They have the total number of people who met the criteria of patients. So I end up, pulling out less data out of those reports. Then there's these bogus numbers in there somewhere where it's like, when you look at the graphs, they just kind of like stick out like sore thumbs, and I take those out because it looks really ugly and they don't make any sense. Set them to none. What else? And I've got some checks in here to make sure that the reason this is in here is because, well, if I get a brand new PDF and that suddenly doesn't fit the thing anymore, I want to get an exception so the thing breaks and doesn't just like, start to have gaps in the graph or something like that. Okay, so we can see that run. And that goes ahead and grabs all of the stuff. You can see that we're missing files, so they list files on their website which don't exist. That doesn't include things that just are not listed on the website at all, so there's possibly dates that are missing. Okay, so, and if we have a look at that, now we've got a nice Pandas. Yeah, I missed the bit in the code, didn't I, where I was like, turns it into a data frame. So turning it into a data frame, it's pretty straightforward. You give it the columns, and then you've just got an array of an array or a list of a list. There's a few other ways of ingesting data into Pandas, but that's pretty much all you have to do. So right, so we got our data. That's pretty cool. Looks good. I've even put in some of this extra stuff, like, these are the people detecting the SQs, non-PUIs. You can start to see that this data doesn't look quite right, but we'll talk about that in a minute. Okay, so the English reports are missing some files. They're delayed by a few days. So the thing is, I had to go and do it in Thai. I had to do all the Thai versions anyway. So there's a lot of this kind of stuff that I discovered. It's like, oh, I just have to use one way of doing it. No, there's some data missing, so I'm going to have to do the other way of doing it as well. And in order, and then combine the two to get all the data. So if I go do that. And we can, when that comes through, so I think this thing doesn't say missing files, but it definitely, I think the initial version, I only did the first page of this, and then I did the rest on the English one, and then there was a reason why I had to go back and do all the Thai ones, because there was some missing data or something. Right, so again, we've got, should be reasonably the same data, because the one's a translation of the other. Okay, so my first time with Pandas. So Pandas, like I said, is like a list of lists. It's a two-dimensional array. It has this nice index feature, so you can pick a column or a couple of columns as an index that allows it to act like a dictionary, right? So in my case, I've got a time series. So my dates are my index, and then I have a bunch of different data that I can keep chucking at it. It's amazingly intuitive. Like it's one of the only APIs where you could say, okay, like I want to do this, and the way you think about doing it is probably the way it works. You can do a lot of different things with it, where you can just sort of slice and dice the data. And I did definitely look up a whole bunch of things, but there was a whole bunch of things that I didn't have to look up that just worked out of the box. Okay, so I'm doing a few things here. First thing I'm doing is that I did a lot of this combined first, so it took a little bit to work out the right function there. But what I'm doing is basically it takes the English situation first and then adds the Thai situation on top. So if there's any missing rows, any missing dates, they'll get added from the second one. If there are any null values, non-NaN values, they will get added from the thing. So it'll fill in blanks, like if there's you saw I set some particular things to none, so they can get filtered by the other data. And if there's any extra columns, they will also get added. So it'll basically just combine it all together, but taking the first one as like priority. The only thing it doesn't do is it doesn't try and check whether if you've got two values for the same column and row, then it's not going to check them and see whether it's matches or not. Interpolate, just in case I'm missing any data, it'll sort of work out a value in between. Now this is quite interesting because I don't know if you noticed, the data I'm actually getting is cumulative data. It's not daily totals. So Pandas, you can just do this. You can say, I take the situation minus 1 day, and suddenly, this is why I had to do the interpolate here, because if I'm missing a row, then it throws it right out. But this will actually turn all my cumulative things into daily totals, which is what I want to graph. And we can see that. Right, so now we're getting PUI counts and tested counts for each day. And so you can see right at the beginning, we had some people of interest. We didn't have any testing data at the beginning because actually that was missing from the PDFs. Okay, so now I get to plot some of this data that I've got. So this is just some extra things to make it look pretty. And then I get to do the situation plot. Now this is supposed to scroll. Okay, why doesn't that scroll? Okay. All right. Okay, I'm going into more detail than that plot anyway. So there's a few different things. First off is if we're going to plot some of those other data, like the not PUI and things like that, the data just kind of looks crap, right? It's cumulative, right? But at certain points it's just kind of added, and the rest of the time it's just like stayed the same value. So things like not with the ASQ numbers and all that kind of stuff, they've just been basically the same. They got added to at some point in the middle of the year, and no one's really bothered to update them. They just keep on putting them in the reports. Doesn't seem to make a lot of sense. It's not particularly useful. But what is more interesting is, so we've got that number, the total laboratory tests that we had. What is total laboratory tests shown? If I just see if we can get a reset at the top. That's better. Okay, so the total laboratory tests shown. That's that blue line there. So again, it's actually following the POI line. So they just add the POI line, and at certain points they added extra to make it higher number. But it's just following the POI line. So it's not really like the total laboratory tests really should be, increasing at a slightly different rate than the POI, and it should be changing. So again, it's not particularly useful data. It's not really the test data. Maybe it represents total people who were tested, and there was we just added in some, at certain points, they sort of caught up on the data and said, okay, these are the private tests, or these are the non-POI people, et cetera, and they added those in. I don't know. The other thing I did in this one is I did these rolling averages here, just smooths out the data a little bit, helps it, so it doesn't fluctuate so much. Okay, so total laboratory tests, that was a bit of a bust. That was like what I was really hoping I could use as a number. So positivity rate. Well, let's still go ahead and look at this positive rate, right? So also called positivity and detection rate. It's basically the positive results over all the total test results. We don't have either of those numbers, but we do have the confirmed cases and the POI, which is sort of correlated, so we can have a look at that. Now, the idea is that if it's under 3 as the WHO number, then you're probably testing enough. And if it's over 3, you probably should be increasing your testing to make sure that you have covered enough people. So I need the cases. So next thing, I need to get the cases from somewhere. So there is a data website that has some nice JSON APIs, and it has a bunch of data, but the only thing I actually got out of there were little cases. It has things like the hospitalizations, the deaths, and stuff like that. It also has a lot of interesting information about the specific cases, which is like, if that wasn't useful to me, but it's there. But it didn't have any of the stuff to do with testing or anything like that. But getting the cases is super easy, right? I've just got a request here. I go straight to the JSON, and all I'm doing is parsing the dates. I found out later you can actually do that directly in Pandas. I just didn't do it the right way. Return data. Okay, so I haven't actually. Right. Okay. So then we get a Pandas data set with all the cases in over time. That's pretty cool. Okay, and then we're going to chuck that into our data frame, and suddenly we've got all our cases next to all our POI numbers, etc. Right. So 65, 2379. So what was this? This was yesterday. We had 68889 and 39 cases. Okay. Right, so now we can actually calculate our positivity. So we're doing the rolling average again, and we're going to, again, it's not a proper positivity, positive rate. It's using this kind of semi-similar data. And we can see that, okay, in April, really weren't testing enough. That's no surprise. All the countries were gearing up their testing, Thailand as well, trying to get the testing happening. Then we had, a lowish rate. There was testing going on. I think we saw that I don't know if I showed that graph before. You could see the graph. There was definitely testing happening mid-year. Again, we kind of caught out during that second wave where we weren't testing enough. And then we also have this big spike here in cases. So a big spike in cases means we probably aren't testing enough. And that's where we are at the moment, around 2%, according to this kind of numbers. Okay. So yeah, the POIs aren't the same as the tests. They don't include things like private testing. They don't include active testing. Whether that's a good thing or not, I'm not sure. It should make an upper bound on the positivity. So tests are only going to be more than the POI, I would expect, which means that the positive rate should be lower if we add more tests, because the confirmed rate, the confirmed cases shouldn't change, but I'll have a look at that in a sec. Okay, then, so that data set that the award and data people were using, that came back online, and it is actually an Excel spreadsheet that's in this folder here. So I needed to get access to Excel spreadsheet. But on top of that, it's actually, if I want to get that every single day, this website is actually not, I can't just use that same routine I had that just got the HTML and got the links out. It's actually using something called WebDAV, which is a protocol for accessing files over the internet, and it's generating that page you saw in JavaScript. So I had to install more software, more Python libraries. So this is, don't worry about seeing the login and password. That's kind of embedded in the page. It's all public anyway. So that's pretty cool. We got a list of all the files that are in that folder. That was pretty straightforward, nice and easy. Now we can download one of them. We can download the latest, when is this? So this is 5th of, these are updated kind of weekly-ish, but there was a big gap obviously in January. So it gives us these positive results and a total. Now, assuming it doesn't give you a lot of documentation, the total, or it didn't when I first looked at it, now they have a documentation section, the total should be the total number of tests, the thing that I was looking for in the first place. Much better, okay. So what's this cannot specify date at the, I don't know if you saw that. There's this cannot specify date and a whole bunch of positives and results now. Okay, so they did actually update the spreadsheet a little bit later on, and they gave a definition of it. They said that there's 11 laboratories that couldn't provide the exact day that those tests came in, but that was all before the 3rd of April. Whether it's a good idea or not, I decided to incorporate that data by spreading it between the dates, before the 3rd of April in proportion to how much tests or positives were at the time. That's what that code looks like. Well, this is all the code. So this is the code that reads that spreadsheet, then does things like I have to get rid of the total row at the bottom. I have to get rid of the cannot specify the date. Then I have to take that stuff and I have to spread it across those rows up until that certain unknown end date, et cetera, et cetera. Okay, and then we get to plot it at the end. So that's what that data looks like. Right, it should be use a rolling average, then we wouldn't get so much fluctuations, etc. Obviously, things like testing slows down on the weekends and stuff like that. That's why it fluctuates a lot. So we can see that there was not much testing in April. There was this kind of constant level of actual tests running around about 5,000-ish mid-year. And we got this massive uptick in testing during the second wave, which makes sense. And the actual positives you can see here, but it's it's a little bit low. So if you have a look closely, it doesn't seem to match so well with our PUI and cases data, which is interesting. So this is the one graph I really do want to show. Why doesn't that scroll? Right. So this graph here, that's this is me just doing the means and stuff like that, the rolling average. Right. This is the really interesting one here. So if we look at, so this is the tests here. So we've got tests versus the PUI. You can see that it actually kind of matches reasonably well, right? So my assumption that, it would be less than the total number of tests, but kind of correlated is not too bad for most of the time. Here, it definitely seems to kind of drop down a bit. There's now we're getting like 3 times the amount of PUIs. I guess that's because of, at this point, we're starting to do like active testing and stuff like that, and they're starting to actually go out and test people, and they don't count as PUIs because they're not people who are, at risk. They're actually sort of people they're randomly testing. Okay, so if we compare the positive results with the cases, then we see some differences, which is kind of interesting. So over here, let's start at the beginning in April. The positives here are kind of hard to explain. I'm not going to try and explain them. I've thought of a bunch of reasons. I don't know. They were gearing up for the testing. They want to test everyone 8 times. I don't know. It doesn't make a lot of sense. But basically, the cases that were reported here, the actual number of positive tests according to this data are way up here. Sure. Yeah, absolutely. I mean, it could be the case that they're testing people multiple times. At its peak, though, it's about 8 times the number of confirmed cases. So maybe they're really not they're not trusting the testing process. They're not just trusting the results they're getting back. So they're retesting and retesting.
When they did the quarantine, people have to go to the hotel.
Yeah. I mean, that's another good question. Like, when did they introduce quarantine? Yeah, that was like later on, I think. They closed the borders and no one could come in for a while until they kind of set up quarantine and stuff like that. Okay, so over here you've got this big discrepancy as well, right? You've got this massive amount of cases. It's the opposite problem. You've got the massive amount of cases without the tests. Well, that doesn't make any sense, right? Like, how can you have confirmed cases with no tests? So a little bit of, let me see if I can go back into this. Okay. So a little bit of digging, I found out that, when they did you remember when they're doing all this massive amount of factories, they're going through all the migrant workers, et cetera, and you're finding like 1,000 cases a day, et cetera. Turns out that what they're doing is antibody testing. Pretty much, it seems most of it was antibody testing. Now, the data set that I was looking at, I think is pretty much all PCR tests. I haven't got a data set for the antibody tests. So that's why that's probably missing. Which means that, again, our testing data is not that useful. We can't really know like what the positive rate is that we're trying to see if they're testing enough. But the other interesting conclusion out of that is that all those thousands of people that they found in the factories, they could have had the virus much earlier. And you don't really know. It could be 6 months earlier. It could be like 2 weeks earlier. It means they probably didn't have the virus then, because if you just got infected with the virus, you'll show up on a PCR test. You won't show up on an antibody test. So it means that at some point earlier, these were the people infected, which is interesting. Okay, so let's look at that positivity rate. Okay. Right, so the positivity rate is kind of interesting. So even though we had that big discrepancy between the cases and the positive results, we end up with quite a similar sort of value for that positivity rate in that first wave there. You obviously get like, here you've got almost no testing at all, right? So the few cases you have just throw the rate right out. So that's And I've got a graph, right? It's quite interesting that we have data for that period because a lot of other countries don't. So that's kind of interesting. It ends up being somewhat the same, and obviously this gets thrown right out because we don't have that testing value is way too low, right? We've got all these cases, and they're not getting counted in there. But there are other tests missing from the antibody. Are there other tests missing? So actually, if you look at those, so what I found next was there is in that same folder with all those with that spreadsheet, there is a whole bunch of PowerPoints, and there's PDFs of those PowerPoints, and there's some PowerPoints. So there's a mixture of the two. It wasn't consistent which one you get. So you got two different data sources, the same content. Now they had these graphs in them. Now these graphs at the end actually have the similar sort of graph. So it has all the tests that were in the spreadsheet that I looked at, right? But it splits it between private and public, which is kind of interesting. So now we can compare the differences between public testing and private testing. What the actual definition is, I don't know. I mean, what it actually means, I guess, private testing should be showing us lower positivity. It should be, yeah, I'm not sure what the conclusions are there. Okay, so now I've got to get stuff out of PowerPoint. Let's try going back to this again. Okay. So first thing we do is we install another library, which gets us these Excel. Okay, so I've used this routine here, which actually gets the information out of the thing. It gives us a bunch of metadata, and it gives us the time series. And so what I'm actually doing here is I'm not just getting information out of a PowerPoint, but I am getting information out of a chart inside of PowerPoint. Okay. Yeah, I thought I had this here. Yeah, so this is the actual code that actually gets the information out of the charts in the slides and stuff. Not too hard. By the way, one thing that I haven't shown is I had a bunch of different routines to get date ranges and things like that, and to translate Thai dates and so on out of all these different things, because getting the dates out of these files was quite important. So if we run that, so it's going to go through a whole bunch of PDFs, a whole bunch of PowerPoints. In actual fact, the final version, in order to get all the data, I had to use my sort of text thing, parse these different dates as text, because we have these PDFs, which loses all the structure of the stuff, but still lets us get the data out anyway. In fact, I think I started with the PDFs first, got the data out, then realized it was missing data, and the only way I was going to do that was by parsing the PowerPoints themselves. Okay, so now we can see what we had in the Excel, which is the blue line, which is actually behind the orange line. So kind of proves that the public what we had in Excel was only the public data. It wasn't including the private data at all. So when it said total, it was only total of public. Now we see the private data. So you can see, yeah, certain points, it didn't have the same peaks. But we can actually put all of them together and try and get a positivity when it got the whole lot together. So then we got three, actually I didn't include the total in this. I did actually do one where I combined them into like the public plus private. How are we going for time? Okay, getting a bit long. Okay. Okay, so this is the public versus the private. All we can see there is that, well, the private during that peak was actually a lot even worse, right? So our positivity for the private tests was worse. What are your conclusion now? Can't say much about this because we're missing a whole bunch of data down here. So I think one of the biggest things about this is if you look at this positive rate, it doesn't tell you the whole story, right? Because obviously we had a second wave, we had almost no cases, so we weren't, things weren't going right somewhere along the lines. And I think what it shows you is that the positive rate really assumes you kind of got this random sampling, or that people are equally likely to get tested. And that wasn't necessarily the case, right? Migrant workers, they have lots of reasons why they may not go get tests. They don't have health insurance, they're illegal status, they don't get time off work, et cetera, et cetera. There's people who don't have, who have a disincentive to get tested. And this whole positive rate thing of, we can be testing all we want in certain areas and in certain, with certain people and still not find cases. So then I parsed one more set of data that was in the same PDFs that actually showed areas. So these areas here correspond to health areas, which you can find on Wikipedia. And they actually break down all these tests. So this is positives here, and this is a number of tests here on a weekly basis. So we can go. Let's go get all that data and show the code for that. And let's plot that. Let's plot that. Once it's done its little calculation, blah, blah, blah. I'll talk about this. Okay, so now one thing about this is that because it's weekly data, or somewhat weekly data, it kind of shows in these blocks. And what I've done is taken that value and spread it across the date period, whether it's a fair way to show it or not. The other odd thing about the data is that if you go to Wikipedia and you talk about like health districts within Thailand, there's 12, but they list 13. I'm assuming the 13th is Bangkok because I didn't see it listed, but I've never found any kind of confirmation of that, so I don't really know. Because Bangkok wasn't listed in a lot of these other groupings. So you can see that if that's true, then Bangkok got the vast majority of the tests, no surprise there. Also, non-Tabriya Kaya and also Rayong Chonburi kind of area, so, around this area. That's where most of the testing goes on, and you can see that there's differences over time with who's getting the test. So Samat Sakon, which is the purple one, you can see obviously that's increased around this time, even though we're not seeing the antibody test here, but we are seeing like an increase around this time. This is the actual positive results, so we can see that over time. Again, there's the Samat Sakon cluster there, as well as what's the brown one. So that's like it's a null. So there's a reasonable amount of cases in there, and this is the Chiang Mai and Chiang Rai. Actually, this doesn't look right. We're not showing a whole lot of tests in Bangkok, are we? So that doesn't look right. Okay, something's wrong with that. Not sure why that's like that. Okay, yeah, so I might have screwed that up a little bit. Then the final thing is to try and work out the positivity across all these different areas. So in actual fact, what I've done here is I've taken the total height for each thing as being the positivity in total for that, and then split it in proportion for the different portion of the areas for the positive test, which is this code here. So you end up where, yeah, like you end up with the total. This line here should represent what the positivity is for the country as a whole. So you can see the positivity went up here, and then the purple bit is again like Simetsucon, like that's obviously pretty bad positive rate. Lots more people being positive than there is being tested. We can see that in a little more detail here if we take off that really big spike at the beginning, and we can see the where else. So all these thin lines should be, pretty good. These are the places that are getting tested to some extent and have very few cases, and the thick bits are the bits that aren't really getting enough love. But don't forget that the data around here with all the antibody testing is missing a whole bunch of stuff, so it doesn't really mean anything. If you want to contribute, this is all on GitHub. If you know other sources of data, then please add them. For instance, there were these infographics going around where they talk about lab results. I assume that this is to do with active testing, and it might include those antibody results. So it'd be great to put that stuff in there. So the one final thing I want to talk about was I scheduled this every single night. So it runs every single night and updates it on every single night. And I did that using GitHub Actions. GitHub Actions probably could be a talk all by itself. I'll just run over it very quickly. Anyone used any CI services like Travis CI, Circle CI, automated testing? Generally, what you use it for is automated testing, right? You check in some code on GitHub, it runs a whole bunch of tests, and it will tell you whether they passed or not. You can get it so that you are not allowed to merge or release any software until all the automated tests agree. So great way for open source projects or private projects to really ensure the quality. Has a bunch of steps. One nice thing about GitHub Actions over other ones is that it has this plugin architecture, so each of these steps can be plugins. You can see this is running here. This one's a schedule one. These are because I've committed code while I'm working on the slides. You can go in and see the output of the different steps, so you can actually see where it's failed. And this is what my GitHub Actions YAML file looks like. So I have to have that Java in there. I've installed Python. I've checked out my code. What have I also? I'm uploading these images at the end of the process, which is kind of cool. I can get it to actually do things. You can do it. You can create Docker images. You can get it to post results to other servers. So all I'm doing here is I'm taking the secret here and posting it to the same GitHub wiki. So they're on the wiki. And this is the bit which installs the requirements and actually runs the test. That's where the secrets go. And that's pretty much it. These are just a few graphs I thought, in case anyone's interested, about where Thailand actually sits compared to other countries. So, we're definitely doing a lot less tests than other countries. This is per head of population. New Zealand's a pretty small country, but they do a lot of tests. Because these are the people that shut down a whole city when they get one case. Obviously, UK and America are doing lots of tests nowadays, but not so much at the beginning. And the share that's positive. So low is good. United States and Germany, not so good. For lots of cases, they're still not testing enough with all their testing. And this kind of shows the two things combined. And that's it. Any questions? Yeah. By the way, I got this today. This is a CO2 meter. So I've been monitoring the CO2 in the room to see whether we're a well-ventilated space. So apparently we're under 600, which is good. So.
I think it masks out the CO2 because we're kind of breathing in our CO2.
So CO2 is a proxy for how ventilated it is. It doesn't matter. It doesn't matter about the CO2. All it says is if you've got too much CO2 accumulating in the room, your room's not ventilated enough. So to be safe for COVID and the buildup of virus in the room, what you really want is the whole room to be changed, the whole air every three times an hour. And if your CO2 is high, you're not doing that. Yeah. Sorry, question.
I had a question about your in the first part of the research when you were scanning the PDF, you were looking for strings, and I've noticed something that there were actually in the numbers there were some regularity where some of the numbers were repeated. Why don't you use that to try to extract the data rather than trying to figure out the strings? Because that may have been also used in the Thai. I'm not sure. In the Thai, just by looking at the number.
As in the POI count was twice in the numbers.
Yes, exactly. Yes.
Yeah, that's true. You could potentially use that. Or as soon as you get the second number twice, you say, okay, that these are just get all the numbers and true. I could have used that. Yeah, that's an interesting idea.
Maybe it was something.
With your GitHub actions, was that like do you want a paid tier or a free tier? I mean, what sort of capacity do you have for running that with your account?
So the question was with the GitHub Actions, is that free? Yeah, if it's an open source project, if it's in a public repository, then that's free. It's covered under whatever plan you're on as well, so you get that for free as part of a paid plan for private repositories. It's capped at, I don't know, there's so many minutes per month or something like that that it's capped on for private stuff. Well, for both, I guess. Yeah. All I know is that Travis used to be pretty good for open source projects, but they've scaled back their stuff, so it's slow and they don't offer really any minutes now. So a lot of open source projects are converting to actions now.
It's like time, right?
Yeah, it could be actually. It could be. Sorry. Yeah.
What is the ultimate goal you have here? And
the ultimate goal, I think, was to kind of like to see whether there was testing enough, right? Like particularly at that point, like the main reason I started the point was because the L1 and data stopped publishing the testing data, and I was like, can I get the POI data and see if there's how much they're testing?
And this is the worst part of the project. Like, why did you try to get government approval to actually go and get the raw data?
The government approval to get it?
Yeah.
Well, it started off very, very small, where I just wanted to get what I had. I didn't want to I wasn't using it for anything.
You were just curious and ended up being a big project.
It's still not that big a project. Like it's not. I showed a lot of. Few days.
Because it seems like more strong user to actually go to the CCSM and actually get the real data, or try to see if you can get help, or go to the backup post and make it like an investigation for them or something like that, right? And get some more support.
Well, so I mean, I work with government clients in my own company. One thing I know about government clients is that they release whatever data they can. They're encouraged to do so. There's all these open data initiatives and stuff. But at the same time, there's a responsibility that goes with data, right? So if you give people a whole bunch of data, then they discover strange things, then it can come back to bite them and it can be embarrassing. So whatever data they've given is what they've given. I don't think they're going to give other stuff if without a really good reason. You'd have to. They're not just going to say give certain data to certain people. So I would say that if I went to them directly and say, can I have this extra data, I probably wouldn't get it. That's my guess.
Yeah, unless they hire you to do the project. It could be a boost to that as well.
Then they need to go and do a tender and so on. So.
There's a question on the.
Yep.
So online question.
Online question. Were any data for PCR test cycle numbers available?
Cycle numbers.
Yeah.
Maybe because when they do the PCR test, they have to do a certain number of cycles to produce
Okay.
the RNA, so maybe it's.
So the question is whether the PCR tests, whether there are any cycle numbers.
The more cycles, the more time it takes to make PCR test.
Right.
So maybe some countries they share this data,
Okay.
to see the reliability of.
There was some extra data in the PowerPoints where they talked about two different kinds of PCR tests, which I didn't really understand. And each week they would show what percentage were these ones versus what percentage were another one. There was also on the website that has all the stuff around the PCR tests. They have all the different labs and so on. They list all the labs and stuff. So there's a lot more information about the sort of testing that could be in there. So have a look at it. I haven't included the links here, but on that GitHub repo, I put all the sources for where I got this information. Tristan?
Part of the investment is that when we can tell people the numbers in Thailand, like in Australia or something, they'll say you're not testing enough.
Yeah.
And do you have an answer to that now that's clear, or do you think the data, despite the results, is still not clear, or what, what's your answer?
Yeah, I think that's what I was aiming for with the positive numbers. I would say that definitely at certain points they weren't testing enough. You know, they're finding all these different cases, and you know, but in general, if you look at the whole lull in the beginning, in the middle of the year, they were doing a reasonable amount of testing with very few cases, and you can do more testing. But the problem is then you're just throwing money at nothing, right? You can do all this randomized testing and stuff, et cetera, et cetera. It doesn't make sense to go out and just test everyone in the country every single day, right? It's just prohibitively. PCR tests are very expensive. I mean, that's why they use those antibody tests, right? They're a lot cheaper. They could be doing other kinds of testing. I don't know, for instance, like places like Australia, they do sewage testing, where you can actually find out whether 1 or 2 people in a whole city have COVID, right? If Thailand's not doing that, they should be doing that. That's a very cheap way and a very effective way to find out if you have any cases with there's very few. But in general, I think, you know, the level of testing seems pretty high. It's not as high as some other places, but there's less cases. So, any other questions? Okay, I think we're getting kicked out. So thank you very much for everyone to come. So if you want to join us at the bar afterwards. So the details are, it is Noi Kwa Roy, which is, if you just follow us, we'll lead the way. Now it is just about 10 minutes walk towards Tung Lo. And I'll also send the link onto the meetup as a comment so that in case you get lost, you can follow us. Thanks everyone for coming. Thanks everyone for online. Okay.